So criterion C3 and C4, discussing the strengths and weaknesses of the experimental design and improving or suggesting improvements to those weaknesses. So looking at the actual method itself, the method steps, describing which steps in detail have affected the results, and explaining the impact on the results, including whether or not you think the data is reliable or if it gives you confidence in the conclusion. You can also look to data or limitations in data in this section. So you can talk about the amount of data collected, whether that is the amount of repeated trials that you were able to do or the number of different independent variable treatments that you were able to do. And you can talk about how that impacts your confidence in the conclusion or how it limits what you can actually conclude or the reliability of your conclusion. In the improvement section, anything that you brought up as a weakness or a limitation, you want to suggest a way to make it better. So you have to really directly link it to the weaknesses and limitations that you mentioned. You want to suggest an improvement that has enough detail that it could actually be carried out. So simply saying that next time you should do something better doesn't really actually tell anyone how they could improve the method step. So you want to suggest specific new equipment, a new technique, new amounts, and try to actually give values and ideas for that. And last but not least, include a suggestion for what you think the improvement, the suggested improvement will actually do to improve the results, improve the data, improve the accuracy or reliability. So if we look at the exemplar lab report, they have a section on strengths and weaknesses of the method. They also have a section up here on reliability of data. So this goes back to that discussing the limitations in the data or the strengths in the data. In this case, the student chose to discuss the reliability of the data first, which meant they were discussing um, how closely did their data points match to their trend line, and how big were their uncertainty or error bars in their graph. So if we look up here, they make comments about how they think their data is fairly reliable because the points are quite close to the trend line. Most of them are on the trend line, or the trend line goes through their error bars. It talks about how most of the data that they recorded was pretty close together, so they felt like it was reliable and they were getting consistent results. They also point to this value called the R squared value, which gives them a measure of how closely this trend line is matching their data. So one thing that you can do is just look at the data you recorded in and of itself and discuss whether or not you think it looks consistent and reliable just in terms of the actual numbers that you were getting. Then you can turn to the method. They've talked about some strengths. They've focused on some control variables. That's a really good place to look when you want to think about strengths and weaknesses. In this instance, they talk a lot about surface area of one of their reactants, which was one of their control variables, and they outline a bunch of reasons why they think that was well controlled. So they haven't just said controlling surface area was a strength. They go into a lot of detail here in this big paragraph explaining their reasons for thinking that the surface area was well controlled, and they talk about how if it wasn't, how that would have impacted their dependent variable, but because they were able to control it, that means they makes their data more reliable. They talk about how they were using a data logger and some aspects of that, why that was a strength, and they also talk about a couple of pieces of equipment. Then they focus on weaknesses in the method. They talk about the amount of data, so the number of repeated trials here, and they get into why they think that made their conclusion a bit less reliable. They talk about the lack of control of temperature, which was one of their control variables, and they explain why they think that was a problem. Again, so they're not just saying the temperature wasn't controlled, that was a weakness. They're actually getting into some of the things they remember about the lab, about their method, that they remember happening, that they have a pretty good insight may have affected the temperature. And so then they explain how they think that would have impacted their data. And they give one more here as well. So you can see that they've given three strengths and three weaknesses. You may not have 3 and 3. That may not be how it works out for you. You might have 1 and 3 or 2 and 2, something like that. But When they have suggested something, they've gone into a lot of detail to try to make it clear why they think that was a weakness. And they've also tried to explain what they think the impact of that weakness will be on their data or on their conclusion. And then in the improvement section, all three of those things that they brought up in the weaknesses have been addressed. They've used these little dashes to kind of separate each one, and that really helps in terms of the layout and the organization. It really helps you see that there are three distinct improvements here, and it's clear that they probably match up. They do a pretty good job explaining that they match up with these three weaknesses here. So you get assessed on how well the improvements match the weaknesses. So by using those bullet points and having 3 and 3, it's pretty clear. You could use a table as a way of outlining, having the weaknesses on the left and then the improvement that goes with it on the right. That would be a way to link them. You could number them. So weakness number 1 could go with improvement number 1. There are different ways to do it, but make sure that they clearly link. And in the improvements, they've given lots of useful details, like improving the number of trials. They've suggested a specific number of trials that is more than before. And they've also explained why they think it's realistic. So they explain how long they think that increasing from 3 to 5 trials would take, and why they still think they would have enough time to do that in a normal class period. So what we don't want is for you to go over the top and to suggest things that aren't realistic, like to suggest 50 repeated trials, because you're not going to have time to do that in class. And then that shows that you weren't really thinking when you were suggesting the improvement. So think about the improvement, make sure that they're realistic for our class, for our high school lab. So they've explained that, and they've explained why they think that would improve the quality of their data. They get into their temperature weakness that they talked about, and they make some specific suggestions for how they could improve it. One is simple, they should have collected all the data on the same day. And the other one is a little bit more detailed or complex, which is using a water bath to submerge their container. And then having it in the water would help control the external temperature at all times. So that's a really specific suggestion about a piece of equipment and a technique that they could use that would improve the quality of their method, that would improve that weakness that they highlighted. So again, overall, they've brought up strengths, they've brought up weaknesses, they've explained them really clearly in detail. They've talked about how they impacted their results. They've talked about data, the amount of data, and they've directly addressed each one of the weaknesses clearly with a lot of detail.